Okay, ladies and gents, this is the first year 12 video I've done in a little while, but this one is on functions. So what you can do is you can use it to do either a recap, or you can use it to go back and make notes, or just as a revision tool. It doesn't matter how you use it. What functions is all about is basically how you get from one set of data to another set of data. Now there's two sets of data that we're looking at here, and we've got the x values, which we call the domain. And then we've got another set of values which we call the range. They should be similar size circles. That's how we get from this one here to this one here. So here we've got a set of values, or elements they call these things. So -3, 1, 4, 6, and x. And the operation, or the function, is to add 3. So obviously that'll go to 0, 4, 7, 9 and x plus 3. So the key thing to pick up here is that the set of x values is what we call the domain, and the range is what it goes to. So in essence, the set of y values. So if we have a look at the other one, let's not have those emails flashing up. Apologies. So if we have a look at the other one, we've got the domain, and then we've got the range. And we've got -1, 1, -2, 2, and x. We're going to square it. So -1 and 1 will both go to 1. So that will go to that one will go to that one. -2 and 2 will both go to the same one, which is 4, and x will go to x squared. Notice on this one, this single element goes to this single element here. But here we've got two elements here, -1 and 1, both going to 1. So that is how we draw mapping diagrams. This here would be the mapping diagram. So the graph would simply be that -3 would go to 0. So if you go to x is -3 and then y would be 0. So that'd be there. Let's do it in a slightly different colour. 1 would go to 4. 4 would go to 7, and then 6 will go to 9. Obviously, if you did this on a proper graph, then you'd be able to draw the graph of it. And so that would be your x value and your y value, or your domain and your range. And then you do the same for the second one here, and you should know what the x squared graph looks like. It looks like that there. Okay, so that's the sort of basic premise behind functions. So let's have a look at some more of the terminology. We've got, well, in fact, just before we have a look at the terminology, we'll have a look at something else, and that's how to remember what a function is. So if we've got a domain and a range, if you've got the domain A and the range, which is B, if you've got one element mapping to one element, we call that a 1-to-1 function. If we've got a domain and an element, and what we had with the x squared, we've got 2 of them going to 1, and that is a many-to-1 function. However, if you've got, well, let's draw a little bit like the previous ones. So if you've got the domain and the range, and you've got one here that goes to a couple of things. So for instance, if you've got any of the trig graphs, or if you've got a square root, so for instance, if it was the square root of x, so for instance, if you had 4, that will go to 2 and -2. This is not a function, because you can't have one element mapping to more than one other element. You can have it the other way around, so you can have two elements mapping to the same element, but you can't have this one here. This is not a function because you've got two you've got an element there mapping to two different elements. That is not a function. Okay, and again, that is worth noting down and worth remembering. Okay, so let's have a look at this one. We've got g of x. So, I mean, g of x is the same as f of x, it's just a different function. So if we had f of x equals 2x squared plus 3, that's the same as g of x, it's just a different function. Or you can write it as y equals 2x squared plus 3. They're all exactly the same thing. And sometimes it's written down as g dot x 2x plus 3. Something along those lines there. And again, it means exactly the same thing. So you've got to be familiar with all these different ways of writing it down and just know they mean exactly the same thing. So for this one here, let's scrub this out. So we've got to find the value of g of 2, which means all we're going to do is we're going to substitute 2 in instead of the x. So it's going to be 2 lots of 2 squared plus 3. And again, we're in A level, so don't make this mistake. Don't do 2 times 2 and then square it. We do the 2 squared and then times that by 2. So that's going to be 2 times 4 plus 3. So that's going to be 8 plus 3, which equals 11. Okay, so now what we're going to do is we're going to do exactly the same thing, but we're going to set it equal to 35 and find out what value of x that is. So we've got 2x squared plus 3 equals 35. So, or 2a squared, to be in line with the question. Okay, so let's just take 3 from both sides. So we've got 2a squared equals 32. A squared equals 16, then we do the square root, so a equals plus and minus 4. Right, so let's get rid of this stuff here. There is a button which means I can get rid of this everything that's on the screen. I can't find that for the moment, so let's just put it out. Okay, so the range of the function. So as we said in this bit here, range is all the y values. So let's have a look at how this looks when we sketch it. So that there is y equals x squared. Again, a bit of revision for C1 now. So 2 lots of x squared. We'll make it look like that. And then 2x squared plus 3 means we're going to move this up by 3. So it's going to look like that there. So the range is just the set of y values. So for instance, y, so if this goes through at 3, y can never equal 2, or can't equal minus 1, or can't equal minus 2.999. It starts at 3 and then it goes upwards. So we can say that the range of the function, so that means that g of x is greater than or equal to 3. And that's how we write down what the range of the function is. Okay, so let's have a look at this here. And we're going to have a look at which these represents functions. And we're going to give reasons for the answers. Let's have a look at the first one. And again, what you can do is you can pause the video if you want and think about what we've talked about so far. And if you think they're functions, then shout out. Or if not, just sort of think why they might not be functions. So A, this one is not a function because you've got one element in the domain. And again, it's worthwhile just getting used to using the words domain and range and knowing what they mean. So we've got one element in the domain mapping to 2 elements in the range. So therefore, A is not a function because you've got one element mapping to 2 elements in the range. Okay, so let's have a look at B. So the domain is our values of x, and every value of x maps to a value of y, so therefore, yeah, it is a function. So it is a function because every element in the domain maps to exactly, or maps to one element, or only one element in the range. Okay, C. So again, here, again, it's looking like it's a function because we've got this value here that only maps to 1, this one here only maps to 1. However, it's not a function. And the reason why this one is not a function is because x here, when x equals 0, it doesn't actually map to anything for 1 over x. So here, 0 doesn't map to anything. So not a function as one element of domain doesn't map to anything. Now that's not to say that 1 over x can never be a function, because it can be a function, but we'll get on to how we make it a function a little bit later. Okay, so for the next one, D is a function. And so this is where you've got to be careful, because we say that A isn't a function because we've got one element in the domain mapping to 2 in the range, but here we've got one element in the domain and it only maps to one element in the It only maps to one element in the range. So let's say x is 4.2 here. 4.2 doesn't map to more than one function. 4.2 and minus 4.2 map to the same one. Let's just pretend that's a straight line. Yeah, so we've got two different elements mapping to the same value in the range. That's okay. It's if one value in the domain maps to more than one element in the range. So if I show you the difference in the graph to highlight this, the square root of x graph looks sort of like that. Keeps rising up. So you've got one element in the domain, which is, let's say, 16, and that maps to two different elements in the range. So therefore, it's not a function. Okay. Okay, so let's have a look at this one. Find the range of the following functions. So what we're going to do is we're going to have a quick sketch of these graphs as well. So if we sketched y equals 3x minus 2, that goes through at minus 2. But okay, so the graph looks like that, and it goes through at 2/3, minus 2, and looks like this. But that's not the range, so we can't say the range goes from anything because the range is only from 1 to 4. So if we have a look at 1, let's use a different colour. 1 starts here, and if we substitute 1 into that, we're going to get 1. And if we substitute 4 into this, and then we go across, 3 lots of 4 is 12, taken away 2 is 10. So the range, so we say that f of x is less than 10, but it will be greater than 1. So that's what we call the range. Don't just assume that the range for this one is infinity or infinite, because it goes up and the y values go up and down forever. But here it specifies what the x values are. Okay, so again, if we have a look at B now. So again, let's sketch this for between minus 5 and 5. Now this is why we sketch it. Because if we sketch between minus 5 and 5, again, it doesn't need to be an accurate sketch, but just so that we get the idea. And that goes up. Okay, let's pretend the graph meets here. Okay, so that's how the x squared graph looks. We all know that. So we have a look at the y values. And the y values go from this point here up to this point here. Now, obviously, 5 squared is going to be 525. and it's going to be minus 5, 25 as the coordinates. So the y values go from 0 up to 25. So we say that g of x, the range of g of x, is less than 25, and it goes up to, sorry, it goes down to 0. So the y values go from 0 up to 25. So that's the range of values. And also the previous one was a one-to-one because everything in the domain maps to one thing in the range. Here we've got, say, 1, which maps to 1, and we've got minus 1, which maps to 1. 5 maps to 25, and minus 5 maps to 25. So that's a many-to-one function. So let's have a look at what 1 over x looks like. Okay, so 1 over x looks like that there. Of course, you've got an asymptote, which is the y-axis. That says that x starts at, or ends at 3, and it doesn't quite go to 0. So what we're going to do is we're going to have a look at the y value. So when x is 3, we go across, and the graph is h of x, or y, equals 1 over x. So y equals 1 over x. Again, remember they're the same thing. So when x is 3, the y value is a third. Now, x doesn't actually equal 0, but let's say x equals 0.00001. 1 divided by 0.00001 would be 100,000. So the y value is enormous. You make x even smaller than that, so 1 times 10 to the power of minus 100, and x will be hugely enormous, a number that you can't really comprehend. So that will keep on going to infinity, which is why it's an asymptote. It will keep going up and up and up. So therefore, the y values range, so we're dealing with h of x here. H of x ranges from the minimum it's going to be, oh, in fact, it's going to be greater than a third. But it will never stop. It will just keep going up and up. So the smallest it can be is going to be a third, but then it's never going to be smaller than anything, so we can just leave it like this. So h of x is going to be greater than a third. Okay, apologies for sort of these lines here. That's just where I was cutting and pasting out of the book. Okay, so let's sketch this one and then state its range. So here we've got two different functions. Well, we've got two different parts of a function making one function. So when x is less than 1, it's 5 minus 2 of x, or minus 2, y equals minus 2x plus 5. So we've got 0 there, so we've got x here, and we've got y here. Let's call x as 1 there. So when x is less than 1, which is this side of the graph, it looks like y 5 minus 2x, so that's going to go through at 5. And when it gets to 1, that's going to be there, which is 3. It's going to look like that there. It's never actually going to quite reach 1 because it says here that x can't equal 1. It's just slightly less than 1. But that's what the graph looks like, except it goes through that point there. Okay, then when x equals 1 and it's greater than 1, it looks like x squared plus 3. So if we substitute 1 into that, that's going to be 4. And we know what the x squared graph looks like. So y equals x squared looks like this. Then we're going to add 3, so it's going to move up like that. So from this point here, it's going to go off like that. So that's our graph. That's what it looks like. So this bit here is when x is greater than or equal to 1. So it's going to be this graph. And this bit here is when x is less than 1. And it is a function because everything in the range, so everything in the domain, which is the x-axis, maps to just one other function. So one other thing in the one other number in the range. We see 1 doesn't actually map to 3 because it can't equal 1. So when it's just behind 1, so 0.99999, that's going to map to that value there. When x equals 1, it maps to this value here. So everything in the domain maps to one thing in the range. So the range of values, so f of x, the smallest it's going to be is going to be, it's not going to equal 3, but it's going to be as close as you can to 3. So you're going to say that f of x, that will be wrong because it can't equal 3. But the y values are all going to be just slightly bigger than 3. Because this one then goes up to infinity, this one goes up to infinity, so the numbers keep rising, but it can never actually equal 3, but it can get really, really close to it. Okay, find the values of a such that f of a equals 19. So what I'm going to do is I'm going to sketch out my diagram again to show how this works. So we had that there, which is 5 minus 2x. And then we had that one there, which is fx equals x squared plus 3. Okay, so we've got to find the value of x, which we substitute in, and it gets to 19. So that's where the y value equals 19. So 19. So if we have a look, that could equal that value there, or it could equal this value here when our line reaches it. So what we're going to do is we're going to set both of these things equal to 19. So 5 minus 2x equals 19. So 5 minus 19 equals 2x. If we swap those sides, so x equals minus 7. We're doing just a little bit of maths there. And if we set the other one equal to 19, so x squared plus 3 equals 19. Now be careful with this one. So x squared equals 16. X equals plus and minus 4. However, for this function here, it's only relevant when x is greater than or equal to 1. So it can't equal, so even though when we square root we get x equals 4, x equals minus 4, when x is minus 4, when x equals minus 4, that goes on to this part of the function here. This one here, which we just solved it for, is only for when x is greater than 1. So we've got x equals 4, and we've got x equals minus 7. Again, take your time, go through that again, read your book, read the textbook about this one, watch this bit of the video again, just to make sure that you're 100% solid on that one. There's lots of little bits and pieces here. Right, now we've got f of x equals x squared, and g of x equals x plus 1. What we're going to do is we're going to work out what fg of 1 is. Now what this means, for fg of 1, if we cover up the f, we're going to stick 1 into g. So we're going to stick 1 into g of x. And whatever answer we get, we're going to stick that into f of x. So if we put a set of brackets around, it's sort of slightly easy to understand. So we're going to substitute 1 into here, work out what the answer is, and we're going to put that answer into this one here. So g of 1 equals 1 plus 1, which is 2. And then f of 2 equals 2 squared, which equals 4. So fg of 1 is 4. Now again, let's try that again with fg of 3. So we g of 3, substitute that in, and that equals 4. And then f of 4 equals, what's this, 16. So again, you put the number into the function that's nearest to it, and then put the answer of that into the furthest away one. So now we're going to do the same with x. If we substitute x in for x, we're going to get, so g of x equals x plus 1. And then we're going to substitute f of x plus 1 into our function here. That's going to be x plus 1. So replace the x with x plus 1 squared. So all we're doing is we're substituting the g function into the f function. Okay. So let's do the same again here. It's slightly tricky now. So the first one is fg of x. So what we're going to do is we're going to take this g function and we're going to substitute it into the f function. So we've got x squared plus 2, and we're going to substitute that into wherever we see x in the f function. It's going to be 3 lots of that plus 2. So it's going to be 3x squared plus 12 plus 2, which equals 3x squared plus 14. Okay, let's have a look at the other way now, because this is an important point to know. So we take the f function, so we've got g f of x now. So we've got the function of x, which is 3x squared, 3x plus 2. Let's try that again. 3x plus 2. However, if we substitute that in for x into our g function here, it means we're going to square it and add 4. So that's what we mean. So we take our f of x and we substitute it into our g of x. So if we do that, that's going to be 9x squared plus 12x plus 4. Again, if you're not sure on doing that, 3x plus 2 times 3x plus 2. And then that'll lead us to 9x squared plus 12x plus 4. Then we add the 4, which equals 9x squared plus 12x plus 8. Now notice that fg of x equals this, gf of x equals this. Now the whole thing behind maths that we learn in primary school is that it's commutative. 3 times by 4 equals 4 times by 3. But here, fg of x does not equal gf of x. And again, that's an important thing to remember. So fg of x isn't the same as gf of x. You've got to make sure that you do it in the right way. So now we've got f squared x. So f squared x simply means f of f of x. So we've got a function of x here, which is 3x plus 2. So we've got 3x plus 2, and we're going to substitute it into 3x plus 2. So it's going to be 3 lots of our x, which we know is that one. Then we add 2. So it's going to be 9x plus 6 plus 2, which equals 9x plus 8. Now, the next one we got is fgb equals 62. So let's work out what fg of x is. So that's our first one, which we handily rubbed out, but again, it should be okay doing it again. You can either just read your notes or just go back in the video. So fg of x was g of x substituted into f of x. So that was 3 lots of x squared plus 4, and then plus 2 on the end, which is 3x squared plus 14. What we're saying is that we're going to set that equal to 62, and I've got to find out what value of b is that makes it equal to that. Well, it says values, so we should have more than one value. So first thing we're going to do is we're going to take off the 14 from both sides. So 3x squared equals 62, take away 14, 52, 48. If we divide that by 3, we've got x squared equals 16. And then x equals the square root of 16, which equals plus and minus 4. So again, that's how you do those ones there. Okay, so, right, this one should say 1 over x. So we've got to now do it in reverse. We've got to find out in terms of m, n, and p what we substitute in to get 2 over x plus 4. So what we've got here is we start off with 1 over x. And if we substitute that into this thing here, then we're going to get 2 lots of 1 over x plus 4, which equals 2 over x plus 4. So what we do is we start off with m of x, then we substitute it into this one here, which is n. So again, this is the one that we start off with, so that's going to be the one that's closest to the x, and we substitute that into the next one. Okay, I've just realised that p of x doesn't actually just equal x. I thought that was a bit odd. In this example, p of x equals x squared minus 2. Thankfully, we didn't need it for the previous example. So let's have a look at the next one. So we've got 4x squared plus 16x plus 14. So here, if we have a look at m of x and n of x, none of them involve an x squared, so we're assuming that p of x needs to have some sort of relevance here. And again, it could be something that you just do trial and error, or you have a look for some patterns. If you have a look at 14 here, 14 I know is 4 squared, take away 2. So if I were to square, I'm going to need to square this to get 16, and I'm going to take away the 2. So if I start with n of x, and again, this might not work, or it might work. I'm going to substitute into p. So let's try it. That's going to be 2x plus 4 is what we start with. Then we're going to square that, so we're going to substitute it into p, so that we're going to square it and take away 2. So it's going to be 4x squared plus 16x plus 16 and take away 2, leaving us with 4x squared plus 16x plus 14. Love it. Absolutely love it. Yeah, that one works. A little shout out, because when I did this one in class, one of my ex-students who's come in to do teacher training picked me up on that, because I got that one wrong, I believe. So thank you, Ruben, for that one. Or Mr. Cartwright. Okay. Next one is we start off with, we've got 1 over 4x plus 12. So let's see, what do we do with this one? If we, because we've got 1 over x, so we're assuming that m needs to be in there somewhere, but if we substitute this one into it, we're not going to get 4x plus 12. And we don't want anything x squared, so we're assuming that p of x, let's get rid of p of x, because I accidentally rubbed it out anyway. So we need to have 4x on the bottom. So in order to get that, what we're going to do is if we substitute 2x plus 4 into itself, 2 lots of that plus 4, that's going to be 4x plus 8 plus 4, which equals our 4x plus 12. Right, so the way we did that is we substituted n of x into n. And now what we need to do is we need to substitute this into our m of x. So it's going to be 1 over 4x, 4x plus 12. That was our n of x into our m. So it's going to be m and n of x, or as we saw in the previous example, might not have been previous, yeah, this one here, where we can write ff as f squared. It's going to be m n squared of x. Lovely. Okay, so now inverse functions. The way to deal with inverse functions, there's quite a bit to have a look at with inverse functions. But we simply write it as y equals 2x squared minus 7. Then what we have to do is we need to rearrange it so that it gets to x equals. So if we do this, y plus 7 over 2, that equals x squared. So getting rid of the 2 by adding it and then dividing by 2. Then x equals plus and minus the square root of y plus 7 over 2. And then what we do, once we've got x equals, we write it as h to the minus 1. So this is how we write the inverse function, h to the minus 1 of x, and we replace the y with an x. So plus and minus the square root of x plus 7 over 2. And that's it. Find the inverse of the function. That again should be 3 over x minus 1 by changing the subject of the formula. So if we write it as y equals 3 over x minus 1, first thing I'm going to do is bring this up, and then we can swap it with that one there. So we've got x minus 1 equals 3 over y, and then we add 1. So x equals 3 over y plus 1. So then if we write that as, what was it, f to the minus 1, so f to the minus 1, the inverse function, and we swap the y's out for x's, so 3 over x plus 1. Now just be careful, because in C3 it's very useful to be able to write this as a single fraction. So again, to write anything with a common denominator, just write, so if it's 1, write it as x over x. So we can say that's 3 over x plus x over x, which equals 3 plus x over x. So again, go through that slowly if you want, not a problem at all. But these two are exactly the same thing, and sometimes they want it written like this, sometimes it's more useful to write it like this. So it's a matter of making this thing here a fraction. Okay. How much more have we got of the... Oh, quite a bit. So, the function f of x is defined by that. They find a function of f to the minus 1 in a similar form, stating its domain. Right, so... let's go through how to do this. So, we've got y equals square root of x minus 2. So we're going to make x a subject, so if we square both sides, it's going to be y squared equals x minus 2. And then x equals y squared plus 2. So y. So it's f to the minus 1 equals x squared plus 2. Now the domain is all the values that x can take. And it's really, there's an important thing here. Let's see if it works for this question. So if we have a look at this one here, let's have a look at the range of values. So it says that x can equal greater than or equal to 2. So therefore, we've got x equals 2 and y equals 0. X equals 2.1 and y equals the square root of 0.1, whatever that equals. And so 0 point something or other. X equals 10,002. Y equals 100. And 2. No, 100, yeah. So obviously the y value keeps getting bigger. So the range of f of x is going to be greater than or equal to 0. Which means that the range of the function, I'm going to write this down because this is an important thing. So I wasn't very clear on that bit there, but so we'll get around to this. That the range of the function, so again, that means that all the y values of the original function, that equals the domain of the inverse. So the range of the original function equals the domain of the inverse function. And when we start doing revision, this thing is going to really come into its own, and we'll be able to spot that time and time again, because they ask you in so many different questions of the same thing. So it says write down the range of the inverse function, and so the range of the inverse function is the domain of the original function. So the range of the inverse equals the domain of the original function. Let's take a second just to have a look at the difference there. Function. So the range of the function equals the domain of the inverse function, and the range of the inverse function equals the domain of the original function. So here it says, again, it sounds very wordy and quite a complex thing to get your head around. but it's not. All the x values and the y values just swap. That's the main thing to remember. So find the function so we found the inverse function and say its domain. So if it's asked us to find the domain of the inverse, that's going to be the same as the range of the original function. So here is the original function, and you just find out what all the y values can equal. So we have a look, x is going to be greater than 2. So when you substitute in 2 and all the numbers that are bigger than 2, work out what the y values are. And the range of y values is going to be the domain of the inverse function. Again, that's something that you might need to watch that bit over and over a couple of times just to really sort of get it embedded. Or you can watch the next couple of questions as well, because I'm sure that it will be very similar. Okay, so here, calculate g of x. So if we've got, g to the minus 1 of x. So if the original function is y equals 2x minus 4, the inverse function, y plus 4 over 2, and that equals x. So g to the minus 1 of x equals x plus 4 over 2. All we did is we made x the subject, and then we write, once we've got x as the subject, we write it as g to the minus 1, as in the inverse function, and then write out whatever that is, just replacing y with x. Now it says sketch the graphs on both functions on the same axis. So zero. So here it says that the domain is x is greater than 0. So if we do the first one, when x is 0, y equals minus 4. And when x is 2, y equals 0. When x is 4, oops, bear with me a second. Yeah, when x is 3, y is 2. Let's do that there. When x is 4, y is 4. And it'll go on like that. So if we then join those points up, the x can only be greater than or equal to 0, so our graph looks like that there. And this is what g of x looks like. Now it asks us to now sketch the inverse function. So if we write that as x over 2 plus 2. So let's see, when x equals 0, y equals 2. Yep. And let's see, when, because we don't know what the domain of this one is. So what we could do is now have a look at what makes y 0. So x over 2 plus 2 equals 0. X over 2 equals minus 2 times by 2, x equals minus 4. So minus 4 lies on there as well. And if we just do another random coordinate for this one here, and say x equal to 4, and there's a reason for me doing this. If x equals 4, 4 over 2 is 2 plus 2 is 4, so y equals 4. It goes through there. Then that looks like that there. So that's just a case of being able to sketch a linear graph. And now what it asks us to do, and this is the key point, what is the connection between the graphs? And the connection is this. Graphs are is the same graph, just reflected in the line y equals x. So if this is the line y equals x. So that is the key thing to note for this functions graph. That the g to the minus 1, so the inverse graph, is the same as gx graph just reflected in the line y equals x. And that's a key point to remember. So once you've done one graph, you know what the line y equals x looks like. It's the diagonal one. And then you reflect it in that line and you get to the inverse graph. Okay, so the key things to remember when you're doing this is that once you've got one function drawn, then you have a look at the x values, and so have a look where they cross both the x-axis and the y-axis, then just swap them over. So if it crosses the x-axis at 2, the inverse is going to cross the y-axis at 2. If the y-axis is crossed at -4, the x-axis on the inverse is going to be crossed at -4. Another thing, and this might be in the next question, I can't remember, but a lot of times they ask you to solve where, let's try that again, where g to the -1 of x equals g of x. Now, sometimes this can be reasonably straightforward to do, sometimes it's not if the function is a little bit trickier. However, when we do this, all we need to do is we need to have a look at where our original line here meets the line y equals x. So here the easiest way to do it is to set, rather than set 2x minus 4 equal to whatever the other one was, x over 2 plus 2, that makes it a little bit more complicated. But because you see where these two lines meet, they meet right here. And that's where it crosses the line y equals x. So all we need to do is either set 2x minus 4 equal to x. In essence, what you're doing is solving y equals 2x minus 4 and y equals x simultaneously. Or you set the inverse function equal to x, so x over 2 plus 2 equal to x. And that will come up with this here. So for instance, 2x minus 4 equals x. Get the x onto one side, get the 4 onto the other side, and you get 2x equals x plus 4, x equals 4. And then because it goes through the line y equals x, if x equals 4, y will also equal 4. So it's going to be 4, 4. Right, okay, so let's have a look at this one. Find f to the -1 in similar terms. So we've got y equals x squared minus 3. I do know this is a long video, and feel free to just do it in chunks or just watch certain bits of it. It's absolutely fine. Y equals x squared minus 3. So you got y plus 3 equals x squared. So x equals the square root of y plus 3. So f to the -1 of x equals square root of x plus 3. And we're going to sketch f to the -1. So if we have a look here, if we have a look at the domain, x can't equal minus 4. Because if we substituted -4 into this, -4 plus 3 will equal -1. We can't do the square root of a minus number. So we can't even have x equals minus 3.1. Because if we substituted that in, minus 3.1 plus 3 is going to be minus 0.1. And you'd still have a negative number. So the minimum this can be, the minimum x value, x is going to have to be greater than or equal to minus 3. So that's what we'd call the domain, because that's all the values that x can be. So x equals minus 3. And if we substitute in x is 0 into this here, we get it going through at square root of 3. And so a graph, the square root graph looks like that there. And well, can't do that there because it's more like that, I guess. Then it continues on, going higher and higher and higher. Let's do the whole thing again. So -3, square root of 3 going up like that. That's much better. Look at that. Y and x. Okay, sketch the f to the -1 of x. So that's what we've just done. So this is f to the -1 of x. and that's the sketch. Then find the value of x such that f of x equals f to the minus 1 of x. So if we were to sketch the inverse function, again, that goes through at -3 and √3, and it looks like that there. And of course, where they cross, as demonstrated on the last page here, is when they go through the line y equals x. So that there. So all we're going to do is we're going to set either this equal to x, or we're going to set this equal to x. Now, I don't particularly like square roots, so I'm going to go with setting the original one equal to x. So to solve it, I'm going to set x squared minus 3 equal to x. So x squared minus x minus 3 equals 0. Then I'm going to solve that. So the way I do that is, so you could complete the square, you could use a formula. So if I complete the square, x minus a half squared, take away half squared, minus 3 equals 0. So x minus 1/2 squared equals 3 1/4, which is 13/4. So if we write that as 13/4, might be a little bit easier. And we're going to square root both sides, so x minus a half equals the square root of 13/2. We can do the square root of all of that. Obviously, it makes no sense now on this line, unless I get rid of that. Now it makes sense. And then you add a half. So we've got x equals a half, in theory, plus or minus, but again, this is going to be the positive version of it. So half plus square root of 13/2, or if you write it as one fraction, 1 plus square root of 13/2. And that's that one there. That's it. Thank you very much. How long did that take? Oh, almost an hour's worth of notes there. Hopefully it will have made some difference though. Feel free to sort of go through it. If this is the first time watching it, thank you very much. Please like, share and subscribe. And check out the fancy new logo as well. Love it. Okay, thanks a lot.